Okay, in this video we're going to take a look at how we can take equations that are in general form and put them into standard form. So that's something like this. A general form equation is y equals ax squared plus bx plus c for a quadratic. And although that's nice and certainly a form of quadratics, it's not the best one for graphing because I can't quickly see where the vertex is and how quickly the shape of this goes up or down. I can see that a lot better if I could somehow transform this equation into a standard form equation, which looks like y equals a times x minus h squared plus k, where we can quickly see the vertex hk and that a value as well, though the a value is actually the same in both. So sometimes this is easy and sometimes it actually gets quite difficult to do. But let's work through a few examples and see how it goes. So here's an example in blue, y equals x squared plus 6x plus 9. And this is a nice, easy example to start with because this is actually a perfect square. If I were to change this, I can change it into x plus 3 all squared. And the reason is that this last number is a perfect square, the first number is a perfect square, that's 3 squared, that's x squared, and the middle number is double the x from here and the 3 from here. So that's that 6x. If it's ever in this form, which we've seen earlier when we did factoring, then we have a perfect square factor, which is exactly what we want to be able to transform this into this equation x plus 3 all squared. And now it's actually in standard form. It's y equals, there's your a value of 1, and then x plus 3 squared, so you can figure out your h value, and then you've got 0 on the end here for your k value. But oftentimes it's not quite that easy. Let's take a look at one more easier one that's kind of set up as a perfect square factor, or perfect square trinomial, and then we'll head into some of them that are a little bit more difficult. So let's see if this is a perfect square. This is 2x squared. This is 5 squared. Is this middle term double 2x times 5? So 4x times 5, that'd be 20. Good, it is. So this is a perfect square trinomial, so we can immediately make it into a perfect square by taking 2x, there's the 2x, 5, here's your 5, and this sign here tells you that middle sign. And we practiced this when we did factoring, and we get a perfect square trinomial factor out of this, and it's a little bit of a better form here. I just wanted to practice your perfect square factoring. We didn't actually make this into ax minus h squared plus k, but I'll show you how to do that in a little bit later. I just wanted to make sure that we understand what these perfect square trinomial factors look like. So let's head back and take one like y equals x squared minus 6x plus 10, and let's see if we can get this into standard form. So what I do is I try to think about, can this be a perfect square trinomial, and what would it need to be? And it turns out that what you do is you take this value here, this is actually your b value, and you divide it by 2. So you cut it in half, so that would be negative 3 in this case, and then you square that. So you're taking all of this and you square that, and that would be 9. And so if there was this form, y equals x squared minus 6x plus 9, it would be a perfect square trinomial, and it would go to x minus 3 squared. So there's your x, there's your 3, there's your minus sign. So let's compare these two things and see if they're at all similar. Well, that looks good, and this term looks good, and these are similar. It's just that I've got that 10 and I'm breaking down that 10 into 9 and 1. So there's a perfect square, this part, and then this plus 1 sits on the end, and I've actually made it into standard form. I've got a value of 1, I've got an h value of 3, and a k value of 1. And so before we go to the next example, again, here's what I did. I looked at this equation and thought, what would I need to add? So it's like move this 10 over for a second. What would I need to add here so that this would be a perfect square trinomial? It's half of this b value squared, which turns into 9. So I need to add 9. Well, I've got 10, so if I add 9, I can use 9 of them there, and then I've got 1 left over on the end, and then I've got my perfect square trinomial. Let's take a look at another one. We'll do exactly the same thing. So I take my b value, I cut it in half, that would be 5, and then I square it, so that would be 25. So what I need is x squared plus 10x plus 25, but I don't have 25, so I have minus 4. So if I move that minus 4 over a little bit, just tuck it over there, I need to add 25, but to keep this in balance, I'm going to just subtract 25 as well. Then so these are equivalent. If I add 25, I have to subtract 25, and I just move the negative 4 over there. So I get x plus 5 all squared. There's your x. This gives you your 5. That gives you your plus sign. And then this piece here is going to sit on the end as minus 29. Negative 4 and negative 25 together is negative 29. And now I can figure out, well, again, a is 1. Oops, it's not b, it's h. H is negative 5, and the k value is negative 29. And I can find the vertex, and I could graph this fairly easily, although the negative 29 is a little bit challenging, fairly quickly from here. Okay, the next one's going to crank the level up quite a bit, so just be warned. So in this case, I have an extra number in the front now, this extra 3, and so that's definitely going to affect things quite a bit. What you need to do now is same as we did before, so think about these first two parts, and we'll just move this 4 over to give us some working space, and then I need to factor out this 3 from the first two parts. And now I want to complete the square by figuring out what to, or complete, this perfect square by figuring out what do I need to add in here. And so our b value is sitting right here. Kind of ignore this 3 for a second, though we will need it in a bit, but this is our b value, and I take half of it, and then I square that. That gives me the number that I need to add here, so that in that bracket I have a perfect square trinomial. So this will now be a perfect square. So what did I add to this side? If I made this a plus 1 here, I actually added 3 to this side, so I need to take away 3 to keep it in balance. And what that gives me now is a perfect square, x, 1, and a minus sign. There's your perfect square, and then this part here is plus 1. And this is pretty nice to graph. I've got a vertex at 1, 1, and I know the a value is 3, so I know it's upward facing, and it goes up quite quickly. Let's take another look at an equation that's like this. We'll do y equals 4x squared minus 16x plus 5. So again, we want to complete this part here into a perfect square, so I'd move this 5 over a little bit, factor this part, and now I need to think about what do I need to add in here so that this becomes a perfect square. And in that case, this is the b value, so I take half of it, I square that, and I'm going to add in 4. That'll create this as a perfect square trinomial. If I add 4, I'm really adding 16, so I need to take away 16, and I get 4, and then I get x minus 2 all squared, and this part here is negative 11. Hopefully we're seeing these steps quite nicely, that when you have y equals ax squared plus bx plus c, what I'm doing is factoring out an a from these first two things, moving that c value over. I'm figuring out what do I have to add in. Let's just move this bracket over here. What do I have to add in here? And so I take half of this new value here and square it. That's what I add in, and then I have to add or subtract, no, add a part over here to balance out adding a piece that's in here, and then I can go and complete that square and get it into the standard form. Let's try two more examples, and I'm going to ramp it up with just slightly more difficult numbers, because that's where I find people start to lose this process a little bit. Okay, so I think about these two, move that 1 over, and I'm going to factor out a 4. As we get a little quicker, I don't really need this step here. I can just start to factor things out. So I've got a 4. That would give me x squared minus 3x. So I just factored out from those first two terms. There's that plus 1. Give myself a little bit of room because I'm going to add in another term here to complete this square. And that part that I add in here, now this is a little bit more difficult because I'm going to take half of this, so that's negative 3 over 2, and square that to get 9 over 4. So that's what I'm going to add in here, 9 over 4. And then I need to figure out, well, what did I really add to this side? I added 4 times 9 over 4, which is like 4 over 1 times 9 over 4. Those 4's can cancel, so I really added 9, so I need to take away 9 from this side as well. And when I do that, I can now summarize. This is a 4, this is a perfect square, this is minus 8, and this part's perfect square is x, and then the square root of this, just like I had 4 to 2, this is a square root, and it's going to be 3 over 2, which is half of this value, and then I use that sign there to get the minus sign. Let's just do one more, and we'll keep that example alive so you can see it. And we'll try this last one. If you want to try this last one by yourself, you can, though it is going to have quite a few fractions in it, which is probably the most difficult part of doing these. So I look at these first two terms, I factor out the a value, which gives me this. That 5 sits on the outside. I want to complete this as a perfect square, and so I take this middle value, I take half of it, so I times it by 1/2, which would give me negative 3 over 4. Then I square that, and that would give me 9/16. And now I added 9/16 in here, but what did I really add? I really added 2 times 9/16, or 2 over 1. This can cancel, so I really added 9/8, so I have to take away 9/8. And so here's my a value. I'll get a perfect square. It'll be x. It'll be this term here, or the square root of, this term divided by 2, or the square root of this term, which is 3 over 4. That sign, which is a minus sign. And now I have to figure out this. So I need to remember how to add and subtract fractions. 5 over 1, take away 9 over 8, requires a common denominator of 8s. This is already an 8s. This has to multiply by 8. And so 40 take away 9 is 31 and 8. And so I have a vertex at 3, 4, and 31 over 8, which isn't a nice location of a vertex, but that's the actual location of the vertex. And I know the shape of the graph. It goes up, and it goes up quite quickly with that a value of 2. Okay, we will get a lot of practice with this in class, and I'll see you then.